Oh, hello. Welcome to video number 15. Yeah, number 15. And we are rounding to given decimal places in this one. So the keywords are rounding, again, which I mentioned in the last video, is just kind of giving an approximation, making something less accurate. Decimal places. So these are the numbers which are after the decimal point in this context here. So in the method, I've put two kind of example pieces again, and you kind of use your initiative to carry on doing it. So to round to one decimal place, you round up the number in the tenths column if the number in the hundredths is 5 or more. So it's all about the 5 or more business again. Keep it the same if it's not. And to round to two decimal places, round the number up in the hundredths column if the number in the thousandths column is 5 or more. Keep it the same if it's not, etc, etc, etc. Okay, again, it makes more sense when you watch the examples. So I'm going to start with number one. Number one, you've got to round this long decimal number here, 345.235892, to one decimal place. That means we're going to chop it off between the 2 and the 3 here. I'll just put a little line in there for you just to show you what I'm talking about. Because that is one, we've got one decimal place, one number after the decimal place. Okay, that's what we want as an answer. So 345 point, and it's going to be either 2 or 3, and that 3 in the hundredths column is not 5 or more, so it doesn't do anything to that 2, and it's going to keep it 345.2. There's our answer to that question, to one decimal place. Okay, now I'm just going to get rid of that line that I drew, and I'm going to draw another line on there because we're rounding to a different degree of accuracy in the second bit. 2dp, that means two numbers after the decimal place. Okay, now the number that is in the thousandths column is 5. All right, so it's 5 or more. If it was more than 5 as well, it doesn't have to be specifically 5. 5 or more. All right, and that's going to do something to that 3. So it's going to be 345 point. The 2 stays the same. All right, but the 3 is going to change to a 4. Okay, and then in the third one, we are going to chop it off. You guessed it. Here, in between the 5 and the 8. Now the 8 is going to do something to that 5. It's going to round it up by 1, and the answer is going to be 345.23, and then we are changing it to a 6 from a 5 because it's rounding up by 1 more. All right. Now this is the least accurate answer. This is the next most accurate answer. This is the next most accurate answer, and the most accurate answer that we could have been given was this one, but rounding just helps us make more sense of numbers. Okay, now in question 2 we've got some words, again some context. The number pi is just a number. Don't be fooled by what pi is. It's an irrational number, but it's just a number. The number pi is approximately equal to, which means it's about equal to, probably could have put that in the keywords, approximately, but it's approximately equal to 3.1415926, blah 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 blah. It goes on forever. I don't remember the digits of it. Who does? Some bloke does somewhere. That's ridiculous number of digits after the decimal point. Who cares? Doesn't matter, right? Round this off to 2 decimal places. So it's just it's just a number they've included. Don't get thrown by it. Here's the number, 2 decimal places. Chop it off between the 4 and the 1. That 1 is not going to do anything to 4, so therefore it's just 3.14. Okay, and in so 3 decimal places, we're going to go 1, 2, 3, and we're going to take that 5, rounds that 1 up to a 2, so 3.142 is the answer to that question, and that is what they ask you to use in exam papers if you do not use your pi button. And I don't know why you wouldn't use your pi button on your calculator. But yeah, if you haven't got a pi button on your calculator, use 3.142 to do any calculations with pi to do with circles, circumference and area. Okay, but we'll get to that later. Now, in question 3, Lenny has rounded a number to 7.3. Write down 3 different numbers the number could have originally been. So this number 7.3, right? If we write down 7.3, think about this example. It's kind of working it backwards, isn't it? Again, with these more complicated examples, 7.3 something. Now, could it have been 7.31? Right? Would 7.31 have rounded to 7.3? Yes, it would. All right. So we could have 7.31. That is a number that it could have been. Could it have been 7.32? All right. well, that still would have rounded to 7.3, wouldn't it? If we chopped it off there, that 2's done nothing. So we could have that. Now let's think of another one. You might be thinking of 7.33 and you'd be right. That would be fine. You could have that. But could we have 7.32, 5, 7, 9, 1? Yeah, we could chuck any numbers after here and it wouldn't make a difference at all to the answer of 7.3, the rounded answer. So I'm going to use that one just to be awkward. But most people would just use 7.33, wouldn't they? All right, but you understand I'm trying to make a point there that it could be any number, all right, that you could choose. There's an infinite number of options and go on forever. I'm not going to go on forever talking about this because I think you probably understand what I've spoken about there. And all I'm going to say is please do like the videos that you watch and subscribe to the channel. I'm going to keep saying that after every video. I know it's boring, I know it's dull, but I'm going to do it because I'd like you to. And yeah, click the link in the description, practice some questions, get better at maths, enjoy it, and be lovely to everybody in life. Won't hurt, will it? Right? Have a nice day.